Algebra 1, lesson 11.6. And this is adding and subtracting rational expressions. So here we go 11.6. Adding. Oops, that's not an A. Sorry about that. Adding and subtracting rational expressions. Okay, so we're going to start out with drawing on what we understand about adding and subtracting fractions, or just in general, adding and subtracting things. So when I do like 5 plus 3, I can say, oh, that's 8, and I can add these things because the 5 things that I have and the 3 things that I have that I'm combining, they are the same size. I have 5 units, maybe I could say, and I have 3 units. And the 5 units and the 3 units, each unit is the same size, which sometimes we can kind of technically we could say, well, we have 5 over 1 plus 3 over 1, and that equals 8 over 1. Okay. What happened? My denominator stayed the same, and I just added the numerators. And it is the same way with fractions. If I had, let's just say I was adding, I was going to go with, hold on a second, let's see. I had another example in mind. Well, sure, I'll just go with this. If I had, let's say I'm adding 1/3 plus 2/9. 1/3 plus 2/9. Okay, well, 1/3, if we drew a little picture to represent how much I'm dealing with there, we have a circle that is cut up into 3 pieces. And how many of those 3 pieces do I have? I have 1 of them. So here's my 1/3. Okay. And then my 2/9, well, if I do another circle, I didn't quite succeed at getting these equal in size, but so this has 9 pieces, I believe. Let's see, if I start 1, 2, 3, 4, 5, 6, 7, 8, 9. Pretend these are all the same size. And I have 2 of these. We'll say I have this one and this one. Okay. Now I can't just add the 1 and the 2 because they're different sizes. I have to get it so that they're the same size. I'm dealing with, in a sense, kind of like the same units, where we could view this 1/3 as I have 1/3 units plus 2 9th units. And they're not that's not 1 and 2/3. Sorry, that's not 1 and 1/3. That is, I have 1/3 unit. You know, I maybe should have not written that as numbers. 1/3 units, and then 2 9th units. And I can't just add the 1 and the 2 to each other because they're not the same size. Or rather, the 1 of what I have and the 2 of what I have, each thing is not the same size as each other. So I need to get to where I'm kind of dealing with the same units here. I have 3rd units here and 9th units here. So what we can do is we can take our 3rd units and we can cut each of these into 3 slices. So now what I'm dealing with has 9 pieces again. And so how many of the 9th units are colored? Well, 3 of them. So this is actually 3 9th units, and then I have 2 9th units here, 9th units. So how many 9th units do I have total? I have 5 9th units, or just 5/9. Now that's just under, or what am I trying to say? Laying the foundation again for what we're dealing with. I know some of you fractions are still kind of a difficult concept, and so I thought laying the groundwork would help a little bit. More, you know, cutting to the chase of how we deal with this with the adding and subtracting of just regular fractions is obviously we say that the denominators have to match. And so if I were just adding 1/3 plus 2/9, what I would do is I'd ask myself, well, can I get the smaller denominator, the 3, to match the bigger denominator, 9? Oh, yeah, I can multiply. And I can only multiply by something equals 1. So I can multiply by 3/3 because that's multiplying by 1. So I'm not changing the value of what I'm dealing with here. I'm just changing what it looks like. So that gives me 3 times 1. That gives me 3 on top. 3 times 3, that gives me 9 on bottom. And now I have 3/9 plus 2/9 is 5/9. Okay? But visually, those little pie chart things, that's kind of like what we're dealing with. Okay? Now, the same applies if what we are dealing with has variables in the bottom. Our denominators have to match. Okay? So we could say if denominators match, add and subtract like normal. Add and subtract, maybe I should say numerators. And use the common denominator like normal. So an example of what that would look like could be like, let's say we have 5 over x plus 1 plus 2x over x plus 1. Okay, so we can look and say, well, do our denominators match? Yes, cool. So we can just jump straight into combining this to be one fraction with an x plus 1. And what do I get on top? Well, I get 5 plus 2x. My numerators add, and my two denominators just become just the one denominator, x plus 1. Okay? You do have to be careful with subtracting, because what if you had something like this? 3 over 2x minus 1 minus 4x over 2x. Okay, two notes of caution. This 4x and this 2x, those cannot do that. You cannot do any kind of simplifying with that, okay? The reason why is this subtraction here. Oops, sorry. I thought it was on the red. This subtraction here is kind of, it's locking this 1 minus 4x to not be able to simplify with that 2x. Unless everything could be divided by 2x. Okay. What I mean by that is if you had, let's say you had 6 minus 4x over 2x, there is some simplifying that you could do here. You could factor a 2 out of the top and say, well, that's 2 times 3 minus 2x over 2x, and now this 2 and that 2 cancel. Because you can cancel if whatever you're dealing with is only being multiplied by other terms, whether it be, in this case, this term is just a number. In this case, this term is a binomial. But we have this number times this binomial. So when you have that multiplication going on like that, there you can do some simplifying. But in this case, we can't cut everything in half because the 1 doesn't divide by 2. All right, so yeah, we're just kind of stuck. But our denominators match, so we can combine these. But you have to be careful. So we know that our bottom is just going to be 2x. Now, what's our top going to be? Our top is going to be 3 minus the whole next thing, 1 minus 4x. Okay, so we have this 3 minus this whole numerator. You have to do the parentheses, otherwise you are not going to, well, otherwise you're not going to get it right, because this minus here gets distributed to this whole numerator. So then what does that give us? That gives us, well, 3 minus 1 is 2, but then this minus negative 4x becomes plus 4x, all of that over 2x. Now at this point, we can do some simplifying a little bit. We can factor a 2 out of the top. So our top can become 2 times 1 plus 2x over 2x. Now the 2 and the 2 cancels, and that gives us a 1 plus 2x over x. That is as far as you can go. Okay, so main thing, be careful when subtracting that you subtract the entire numerator that comes after that. Okay, so that's where the denominators match. Well, if the denominators do not match, if the denominators do not match, multiply by fractions equal to 1. I can say top and bottom are the same. Top and bottom are the same. To get the denominators to match. So let's do a couple examples like that. That might look like this. Let's just say we have x plus 1 over x plus 5 over 3x. Okay? So I look at my denominators. The one on the left is x, the one on the right is 3x. Those don't match each other. But you know what? No, I'll just leave it like this. But what can I multiply the first fraction by to get its denominator to match the second denominator? Well, I can multiply by 3 over 3. I can multiply by 3 over 3 because that's equal to 1. Therefore, I'm not changing the value of what I'm dealing with. I'm just changing what it looks like. And then if I multiply it by 3 over 3, the 3 in the bottom makes this denominator become 3x, which then matches that one. So what that's going to look like, that's going to look like 3 over 3 times x plus 1 over x plus 5 over 3x. Okay, now we have to distribute. So this 3 gets multiplied by that whole denominator, just like we were saying we have to be careful when we subtract, that we subtract the entire numerator. In this case, when we're multiplying by 3, we have to be careful that we multiply the 3 by the entire numerator or denominator, but there's no distribution to happen with this denominator. So this is going to give us 3x plus 3 over 3x plus 5 over 3x, and then we can combine these. So I know I'm going to have a 3x on the bottom. What's my top going to be? 3x plus, well, 3 plus 5 is 8, 3x plus 8. And that is my final answer. There's nothing, you should check every time, is there anything I can factor out that might lead to simplifying? Can I do any factoring? Can I factor anything out? Well, I see that I have a 3 and a 3 there, but 8 is not divisible by 3. If this had been 3x plus 9, then I could have factored a 3 out of the numerator, and that would have canceled with the 3 in the denominator. Okay, so that's one flavor what that might look like. Let's how about something like this? Because sometimes you might have to multiply both denominators by something, or both fractions by something. So let's say we have 7 over, what was I going to deal with? Let's go with 5x squared plus 8 over 10x. Okay, so we look, do our denominators match? No. What can I do to get them to match? Well, let's see. My first one, if I took this 5 and multiplied it by 2, that would give me a 10. That would leave me with a 10x squared. Oh, but this one has an x squared, whereas this one only has an x. So if I multiply the second fraction by x over x, that will give me a 10x squared on the bottom. Or that'll give me a 10x squared as well. So the first one, I need to multiply by 2 over 2. So 2 over 2 times 7 over 5x squared plus 8 over 10x times x over x. You can multiply the x over x before. I just oftentimes end up putting like the middle as what I originally had and the outside. I don't know. It's just, yeah, how I tend to do it. All right. So what do we have here? So 2 times 7, that's 14 over 10x squared plus 8x over 10x squared now. So I can combine these now, and I have 14 plus 8x over 10x squared. All of the numbers that I have there, all the coefficients are even numbers, so I can factor a 2 out. So let's see. So that's going to give me 2 times 7 plus 4x over 2 times 5x squared, and that 2 cancels. So I'm left with my final answer being 7 plus 4x over 5x squared. Do not do anything canceling these x's because that plus sign there makes it so you cannot do any simplifying there. Okay. And then sometimes the denominators don't match at all. And so you might have something like this. You might have something like 3x over x plus 1. We'll say minus 4 over x minus 3. Okay, these don't match. Yeah, they don't match at all. So when that's the case, then what you do is if we multiplied this first chunk by the second denominator, top and bottom, in other words, we multiply this first chunk by x minus 3 over x minus 3, my bottom then is x minus 3 times x plus 1. Then if I multiply the second fraction by x plus 1 over x plus 1, then my second denominator is x minus 3 times x plus 1, in which case they match. So sometimes you just have to multiply the first fraction, top and bottom, by the second denominator, and then the second fraction, top and bottom, by the first denominator. And sometimes that's as good as you can do. So I'm going to do x minus 3 over x minus 3 times 3x over x plus 1 minus 4 over x minus 3 times x plus 1 over x plus 1. Okay, let's see what we get. We're going to have to do some multiplying here. So I know my denominator here is going, and I would just leave it as x minus 3 times x plus 1. That, I would just leave it like that. But our numerator, we got to do some multiplying out. So we have this x times 3x, that's a 3x squared, minus 9x. And then here we have minus, well, let's see what my I know my denominator is going to be an x minus 3 times an x plus 1 again. And what I have 4 times x, so 4x plus 4 times 1, or 4. Okay, now what can we combine here? Well, I know my denominator is just going to be this x minus 3 times x plus 1. My numerator is going to be a 3x squared. There's no other x squared term to combine with. Now I have minus 9x minus 4x. Minus 9x minus 4x. So that's going to become minus 13x. And then I have minus a positive 4, which is just minus 4. All right, now we need to see if the top can factor. If the top can factor, I'm not quite sure it can, but I'm going to work over here on the side, on the left-hand side here. So I have a 3x squared, so 3 times negative 4, that's negative 12. I'm wondering if there are two numbers that multiply to be negative 12 and add to be negative 13. And no, there aren't. Because I could do a negative 12 and 1, but that would add to be negative 11, not negative 13. So nope, it can't factor. So that is as far as it can go. So that was my answer. It's kind of ugly, but that's what it is. Okay. That should give you a good feel of what to do. Other than that, let me know if you have questions. Cool. Hope it goes well.